Good afternoon, everyone, and welcome to this session on writing custom views for Android. And the title is actually a little bit misleading because we won't be showing code or we won't be writing code. My name is Romain and this is Adam Powell, and we both work on the Android framework team at Google. Adam works a lot on the UI toolkit, and you have seen his work in the action bar, the view pager, the support library. He's the mind behind all of that. I focus mostly on graphics, performance, and animations, but I've done a little bit of UI toolkit in the past, so I think I know what I'm talking about.
OK, so why would you actually want to write your own custom views? Isn't the framework good enough for that? Are we missing something? Well, usually the framework has what you need, but between the framework and the support library, you kind of have what you need to get everything in the design guide. And reusing those framework components ensures that the user is familiar with the patterns there, and hopefully the components are stable. But sometimes you just really need to stand out. So, I mean, just like Larry was saying this morning, your app is doing something unique, right? So otherwise, why are you writing it? You might need graphs, other data visualizations, other things that just are really unique to what your app is doing. Maybe you need some sort of custom interaction with your content. I mean, not everything fits within a list view or a scroll view. And touch is a great way to feel connected to your content, and writing a view gives you full control over that. So who here uses relative layout, for an example? Oh, a lot of hands. That's great. Probably because this guy told you to.
Now, a while ago, I wrote a blog that was misinterpreted, and now everybody thinks they should be using relative layout all the time. Please don't.
Well, I mean, it's a great view, right?
It works. We can get to that later if we have time.
Sure. So relative layout will measure child views more than once in order to solve some of the constraints that you give it. So being generic has a cost. A little domain knowledge can go a long way for optimization. And really, there should always be one part of your app that can catch someone's eye from across a room, something that's instantly identifiable. If one of your users is using your app in a coffee shop, someone clear across the room should be able to tell what it is. So you want to make your app fun and satisfying. And the design guidelines are great, but apps that do unique things will always beg for some sort of innovative ways to do them. So members of the Android community have already given several talks lately that have been really great and given a lot of information on writing custom views. And not only that, there are a lot of great code examples available. And Android open source project itself is a great resource for you to look at. But realistically, we kind of want to keep this talk a little bit more abstract, as you were saying earlier. So in writing our own custom views and helping others write them as well, we found a lot of common patterns emerged from this. And we found ourselves giving the same recommendations over and over. And we're going to spend most of our time here today talking about those experiences and what worked well, what didn't, and what can really help you from getting caught in a rat hole of the internal design of your components. So to do that, we still need some context about how the system works. So we'll go ahead and start with
life overview. But just before on the last slide, on the previous slide, don't believe the tips and trick bullet. We removed that section, so there won't be tips and there won't be tricks for you today.
Well, we might have some tips and tricks along the way.
Yeah, along the way. So we'll start with life overview. So how many of you have ever seen the activity lifecycle diagram? All right. How many of you understand the activity lifecycle diagram? You're a bunch of liars. I've been on the team for 6 years. I still don't get it. I exaggerate, but it's complicated. But the lifecycle diagram of activities makes guarantees about the methods that will be invoked on your activities and when. And we have similar things for views. It's a lot simpler, as you will see, but we have guarantees that we can promise. So the life overview is made of 3 things. We have the attachment and detachment, and this is actually a very important part of the life overview, and I've never or rarely seen articles online talk about it or examples focusing on that. Then we have traversals that you may know as drawing and layout and measurement. And finally, we have the state saving and restoring. So let's get started with the attachment and detachment. Actually, another quick poll. How many of you have used that method on attach to window? All right, that's pretty good. So whenever you attach a view to a parent, so you call view group.addView, if that parent already belongs to a window, in UI Toolkit parlance, we said that the view gets attached to the window. So you get this callback on attached to window. And this is where the view knows it can be active. So this is where you should start allocating any resources you might need. This is where you can register listeners on other pieces of the application or the system. And for instance, in list view, when you attach a list view to a window, this is when we attach a listener to your adapter so the list view knows when the data changes in the adapter. And again, you should take a look at the source code of Android. So if you look at the source code of view.java or apps.list.view.java, you will see the kind of things that we do in unattached to window. But even more important is the second callback called undetached from window. So we call that callback whenever a view is removed from its parent and if that parent is attached to a window. This can happen for a number of reasons. Maybe the view is getting recycled in the list view when you're scrolling. Maybe you called remove view on the parent of that view. Or maybe we are tearing down the activity. When we tear down the activity, when there's a finish event on the activity, we're going to remove every view and we're going to detach them from the window. This callback is very important because this is where you can stop doing any kind of work that was already scheduled. So if you had scheduled an animation, like a scroll or a fling, if you had a background thread running, you can stop those things right here. Also, if you had allocated resources like a drawing cache of some sort or any other resource that your custom view might need, this is a very good place to clean up those resources. A good example is for the hardware renderer. So in Android 3.0, we added hardware acceleration. And we create a lot of native objects that we attach to views during the lifecycle of the view. And when the view gets detached from the window, this is where we can destroy those native objects because we know that the view will not be shown on screen anymore. So we make you that promise. When you get undetached from window, you can destroy all these resources. Of course, this is a promise that we make. But sometimes when you implement your own custom views and you try to be let's say, smart about the lifecycle of the view, you might run into weird issues where the view will be detached, but it's not, or the view will think it is detached. It is not detached, and it is. We've run into a number of bugs like that in our own applications.
A couple.
So be very careful when you use add view, remove view, and view group has a number of methods where you can temporarily detach a view from the window. So if you're using those methods, be very careful. And that's about it for the lifecycle of a view. So what is missing? What is missing is all the events that you get on an activity. So things like on pause, on resume, on stop. And we have a lot of requests from people who are asking to get those lifecycle events on view itself. The reason why we don't have those lifecycle events on view is about abstraction and layering. The way the Android framework is built, we try to layer our packages on top of each other. So what you see on the slide right here is actually the layering that we have internally. So the Android.app package that contains activity and context sits on top of pretty much everything else. At the bottom, we have Android.widget, where you have your text view, your list view, your image view, things like that. And that sits on top of Android.view. So you could actually build a version, I would say a fork of Android, where you get rid of Android.widget and you just keep Android.view and the system would just work. So instead of adding those activity lifecycle events to views, what you should do is create your own sets of listeners or callbacks in your custom views. So here there's a very simple example of a custom listeners that you could specify on your view, and it will be the responsibility of the activity to invoke those callbacks on the view. Another way of doing it is just to add methods straight to your class. If you have used GL surface view that used to do OpenGL rendering, this is what happens. This view has its own on pause, on stop, on resume methods, and it is your responsibility when you add that view to an activity to call those methods at the right time. So we don't need to add support for that in the framework. You can do it yourself. We know it's a bit more work, but you can easily write utility libraries or classes in your code to help you do that. I briefly mentioned traversals before, and traversals are scheduled in 3 different ways. They can be scheduled by animations, and we're talking about the new animation system that was introduced in Honeycomb. The old animation system is actually part of drawing. Traversals can also be triggered by request layout and invalidate. And this is what the traversal looks like. And if you want to be really scared, go look at viewroot impl.java in the source code of Android, and look, there's a method called perform traversals, and try to understand what it does. Once again, I've been writing code in that method for years, and I still don't quite get it. Don't laugh, it's true. So we first start with animation. So with the new animation system, there will be callbacks related to animations that will be triggered at the beginning of a traversal. Then we're going to do the measurement pass, then the layout pass, and finally the drawing pass. The order that you see those events on screen is guaranteed. You will never see a draw. Well, let me rephrase. If you see a layout, there will always be a draw after. You can't see a draw and then the layout. What can happen, though, is you could have a measure and a layout and not a draw, or you could have a draw but not a measure and a layout. The only tricky part here is that the measure and the layout always happen together. You cannot have one without the other, unless you're doing something really bad in your application.
All right, so let's dive a little bit deeper on some of these topics. So measurement and layout is where we'll go ahead and begin. All views know how to measure themselves and lay out their content. And leaf node views that don't actually have any children should measure their internally displayed content and go ahead and lay that content out during these 2 steps. So view groups, on the other hand, organize, measure, and lay out a series of child views. So request layout is the first step in this whole process. At some point, when some piece of state changed within your view, request layout is the signal to the view system that it needs to recalculate the measurement and layout of the views. So it means something very specific in terms of what changed. It means that something changed that can alter the size, and by extension, the layout within all the ancestors moving up the hierarchy. So request layout is recursive. A change in the size of a leaf node way down at the bottom of the tree can influence the size going all the way up the tree as well.
Yeah, and this is actually one of the reasons why we often mention that you shouldn't have too many views in your application, in your UI. And more importantly, we said that you shouldn't have too deep of a tree. And this is one of the reasons, because every time we call request layout, we'll have to walk all the way back up. So when you call request layout once, it doesn't really matter, but if you update a lot of views and every one of them tries to go back up the tree, it can take up a significant amount of time. We have optimizations in the UI toolkit to avoid doing extra work, but every bit can help.
That's right. So because of this process, anything can change. It can dramatically change the way that the view's parent, grandparent, or great-grandparent measures and lays out the other views around it. So on measure is where your view implements the measure step. It's called by the actual measure method within view to determine the view's size. In a view group, again, this is a recursive process. So view groups will go ahead and call measure on each one of their child views, and then they can use the results to help decide their own size. So the parameters to onMeasure are these packed measure spec values. They're packed into a 32-bit int. So the makeMeasureSpec method goes ahead and packs a size and a mode code into these values. And then the getSize and getMode methods listed here unpack them for you. And we'll go ahead and talk a little bit more about measure spec modes in a bit. When a view group is measured, it has a responsibility to make sure that its child views have been properly measured as well. A layout request may have originated from a leaf node deep down the hierarchy, and depending on how a view group decides to arrange its children, one small change in size down at a leaf node can drastically alter the layout above it. If this sounds expensive, it's because it really can be. Multi-pass measurement in a view group is sometimes necessary when you're trying to resolve different constraints for a layout, and because of that, it can really add up fast. This is usually a good time to dust off your algorithm analysis techniques. So finally, onMeasure doesn't actually return a value. Instead, you call setMeasuredDimension to set width and height explicitly. This is enforced. If you forget to do this, then the framework is going to throw an exception and crash your app. The sizes that you set here are reported by the getMeasuredWidth and getMeasuredHeight methods, not the normal getWidth and getHeight methods you may be familiar with. This is because the process is two-step. GetWidth and getHeight don't actually have their values initialized until layout is complete. So you can use the measured size of these child views to decide your own size or perform any other bookkeeping after the child's measure returns. So back to modes. Well, there are 3 different modes. The first one is exactly, and it means exactly what it says. This mode can be used if there's a fixed size specified or if the parent view has otherwise calculated a fixed size for it. So if you're familiar with the match parent that you might set in a layout params, or weight that you might use in linear layout, these are good examples of when we might use the exactly mode. It's common to go ahead and do a second pass to finalize a measurement in a multi-pass scenario, and weight is one of these, since we distribute whatever leftover weight is still remaining after we've measured all the child views. We use exactly to go ahead and lock in the extra size to each one of the child views. So at most specifies an upper bound with the implication that the view should usually be conservative with that. The measured size should always be less than or equal to the size reported in the measure spec. When you give a view a width of wrap content, then the stock framework layouts will use at most to measure that child. The view has the option of consuming up to that specified size if it really wants to. And finally, you have the unspecified mode. This is where we just really don't know anything enough to tell you how to measure this in this particular dimension. The view has potentially infinite space available to it. So this is really common for things like scroll containers, so scroll view, list view, et cetera. The limits are based only on the content that you're trying to place there. So most views still treat this the same way that they do with at most. They just don't impose the upper bound constraint. The implication is that the view should still try and be as conservative as possible and wrap tightly around the content. So making sure that you actually get the right measure specs that match what your child views want, it can be a little bit tricky. There are a few utilities in the framework that can help out with this, though. One of these utilities is the getChildMeasureSpec method. It understands the standard framework patterns for how layout params and measure specs should interact with one another. It's kind of a handshake between the two that happens during measurement in the parent. So, for example, if a parent has exactly 300 pixels available to it and a child wants to wrap content within it, then the spec that we'll actually send to that child is 300 pixels and the at most mode. So once measurement is complete, layout is just a matter of positioning the child views that we've already measured. So usually this is where we apply offsets, padding, margins, so on and so forth. And while view groups can often implement multi-pass measurement to get things just right, layout will generally only happen once. If there's some expensive computation that you need to perform during the whole measure layout sequence, then you should really try and defer it to layout if you can to be more efficient. That way you don't get caught up in these multiple measure passes that can happen. And even if your own custom view doesn't do multiple measure passes, some view that's further above you in the hierarchy may be performing that. So you still want to be as optimal as possible. So this two-phase measurement and layout means that you'll often want a way to get at some of the data that you've already computed in on measure so that you don't have to compute it twice. Get measured width and height are always there for you to use for this purpose, but sometimes you need to have more info than that. You'll want a way for child views to communicate extra configuration data to your layout code in general, such as gravity, for one example.
Yeah, we're going to talk about layout params, but just before we get started, so we mentioned the 3 different measure spec modes. It's a little scary and intimidating when you try to write a custom view and you think about, how can I implement all those modes? You don't have to. If you write a custom view and you know exactly how it's going to be used in your UI, like it's always going to be match parent, just implement the measure spec exactly. Like that's the big difference between what you can do in a custom view. You can cut corners, you can cheat, you can make it a lot more efficient, and what we can do in our views in the framework, because we have to make them work in all possible situations. So our code is a lot more complicated and harder to optimize than what you can do. And this is why we keep telling people, you should try to create custom views whenever you can, because you can make them a lot easier to write and much more efficient than the ones that we have. For instance, if you are trying to use all the default widgets that we have in the UI toolkit to create a really complex UI and it doesn't quite work, you can write a custom view instead. Like it's going to be easier. You might spend less time writing that code, that Java code, than trying to come up with the magic XML incantation that's going to do what you want. And it's also going to be more efficient. So to create the measure specs for your children, if you're writing a custom view that extends view groups, so if you're writing a custom layout, you will be very interested in layout params. So layout params, you know what they are from XML most of the time. They're all those attributes that start with layout underscore. and they map to a class that is typically called layout params, and it's a static inner class of the layout it belongs to. So the base class is called viewGroup.layoutParams, but we also have linear layout.layoutParams, we have frame layout.layoutParams, and so on. You don't have to do it this way, this is just the recommended way. The base layout params class will give you a width and a height. There's another one you can use, it's called margin layout params. It will give you the extra margin parameters if you need to support margins in your custom group. So layout params are really dumb objects. They're just here to store data. They just store the arguments that you're getting from the view when it's added to the view group. So either from code, when you say add view, you pass the view then a set of layout params, or from XML, you can inflate the layout params from XML. And you know about width and height, but in linear layout, we mentioned the weight. This is one of the params that we store in linear layout params. It's always a mouthful to pronounce those things.
It is.
We need to rename them. Beyond layout params, so if you create custom layout params because you want more than the width and the height, there are 4 other methods that you should implement in your custom view group. So we have one called check layout params. This is invoked when you add a view to a view group. If that view already has layout params attached to it, we're going to call check layout params to see if those layout params are compatible with the view group. So usually what views do here is just an instance of check. So if you look at linear layout, it just does the parameters instance of linear layout.layout params. But you could do a lot more. If you have a lot of custom parameters, you could validate the constraints, for instance, and throw an exception if they don't work. Generate layout params that takes a layout params attribute can be used to do conversion. So if you add a view that was previously in a frame layout and it has frame layout params, and then that view is added to your view group, and if you know how to convert those frame layout params in your layout params, you can do so in that method. Generate layout params within an attribute set. This is what's used when we inflate the layout params from XML. So the default behavior here that we use, actually that's what we use all the time, we just call the constructor of layout params that takes the attribute set, and all the work is done there. And finally, generate default layout params. If you don't specify layout params when you add a view from code, we're going to try to guess what's the best configuration for a view group. So typically in a frame layout, we're going to do match parent. A linear layout will do something like wrap content, something like that. But don't forget that layout params can also be used to store private data. So if you do a lot of expensive computations during the measure pass or even during the layout pass, you can store all that data per child in the layout params. So if you go look at the source code of relative layout, for instance, that's exactly what it does. It has its own private fields to keep track of what's going on. I want to talk briefly about drawing. We won't spend too much time on it because we have a lot of other sessions about rendering. But the way to trigger a drawing traversal is to call invalidate. I'm sure a lot of you are familiar with that method. And just like with the request layout, it's a recursive algorithm. So it's going to walk up the tree. It's not going to call invalidate on the parents. It's going to call something called invalidate child. And those methods are actually pretty expensive. Request layout is pretty cheap because all it does is sets a flag saying, I want to layout. Invalidate has to keep track of animations, of bounds, of transforms, things like that. So if you go look at the source code, if you're curious, you'll see that it's not a trivial method to call. Again, we try to optimize those calls. So if you have 2 siblings of a view group that call invalidate, only one of them will go all the way up. Calling invalidate without any parameters will mark the entire view as dirty. There's a variant of invalidate that takes 4 parameters. It's a subrectangle of the view that you want to redraw. So whenever you can, if you have enough information about what's going on inside the view, try to use the second variant of the method. It will be a lot cheaper for the UI toolkit and for your application to do the redraw when we come back down. So once we call invalidate, we're going to call the draw method on your view and possibly on other views. So the draw method in the base view class is final. You cannot override that method because it does a lot of bookkeeping that we don't want you to mess with. And trust me, you really don't want to have to deal with that. Draw will invoke other methods that you can override. So the first one is called onDraw, and I'm sure a lot of you are familiar with that method. So how many of you have ever implemented the onDraw method? Okay, that's really good.
Good, lots of experience.
So the only goal of the onDraw method is to draw the content of the view. You don't have to draw a background. The base view class, the draw method, will do that for you. But any other content you want to draw, like text in a text view, that's where you do it. There's a little trick. We have a method that, I hate that name, it's so confusing. Set will not draw true. So it's Yeah. Again, after 6 years, still get it wrong every time I try to use it. And it's even worse because internally it's implemented as a bit inside the int. So with all the mask that you have to use, it gets really confusing. View group by default will set that flag. So when that flag is set, so you promise that you do not want to draw anything. Your children will draw, but you're not going to draw anything. You don't have a background. You don't want to draw anything on top of your children. So in that case, we're going to skip the onDraw call, and we're going to call directly another method called dispatch draw. And dispatch draw is another pretty complex method, but you can override it. That's responsible for drawing the children. And this is where we apply all the transforms, like the alpha, rotation, scaling, and animations with the old animation system. And for every child, we call a method called viewGroup.drawChild. So if you want to override that method entirely, make sure that you call the drawChild method for every one of your children. Otherwise, you're not going to get animations working or transforms. There's a big difference between software and hardware rendering in the way we call those drawing methods. So as I mentioned before, we introduced hardware rendering in Android 3. And in software, if you call invalidate, we're going to call the draw method of every view that's a parent of the view that called invalidate. We're also going to call the draw method of any view that intersects with the dirty region. So if you have views stacked on top of each other, and even if they're siblings, we're going to call the draw method on every one of those views. So it can be pretty expensive. In hardware, however, we have a completely different system, and I won't go in details here. There was a talk 2 years ago explaining how it works exactly, but only the view that calls invalidate will see its draw method invoked. This is much more efficient. You can imagine that if you have 10 parents, and suddenly we have to call only one method instead of 11, it's going to be a lot faster. So you can refer to that talk, Accelerated Android Rendering, where we explain in details how the new rendering system works.
All right. So a lot of your views are going to have instance state. This is some extra information that you're going to want to be able to save for later. Android app components can come and go at any time, remember? So process containers get killed, activities get recreated if you change the orientation or something else changes. But views can actually save their own state for later in a way that can be persisted by the system. So two methods control this save and restore process, named onSave instance state and onRestore instance state. And the easiest way to write one of these instance state objects that gets persisted is to extend the base saved state in a static inner class of your view. And this establishes conventions for how subclass and superclass state get organized within this persisted bundle. So the standard naming convention is just an inner class called saved state within your view. Views need to have an ID for their instance state to be saved and restored. This is really important. This also needs to be unique within your view hierarchy. This is how we actually match up what data to pump back into the onRestore method when your views get recreated. So if you duplicate the ID within multiple views within your hierarchy, we're going to restore that same state to multiple views, which probably isn't what you want. So the mechanisms behind actually saving the instance state are pretty well documented, but what you save is a more interesting question. Don't bother saving anything that's a part of your data model. Instead, save things that are a reflection of the view's state as it relates to the user's interaction with it. So you really want to keep these concerns as separate as possible. Normal data loading within your app is going to take care of reflecting the state of your data model. There's really no reason to save it a second time and have multiple sources of truth. Instead, the view instance state should take care of leaving the details where the user left them. So things like uncommitted user input can be a little bit of a gray area in this, like text entered in a field if you have a really long form, for example. Many cases, we'll go ahead and save this for you. So edit text will automatically persist whatever text the user's entered.
So basically, you're telling people to not be like a web page? Like when you reload the web page and all your stuff disappears?
Yeah, basically. So next, we have touch events. Touch events are fun. They're really a key component of any interactive view these days. So the basic event handling, again, is well documented. But what happens when it gets more complex? What happens when you actually have views at multiple levels of the hierarchy that need to sort of negotiate? Well, first off, it's important to know what a consistent event stream means. Android has this idea of a consistent event stream when it comes to motion event objects. This is a guarantee from other parts of the view system to your views. You really shouldn't break this guarantee when you write your views and you end up sending events to other views. You want to make sure that these guarantees hold. So action down starts a new gesture. It's really the beginning of a touch interaction. It's when the first touch point contacts the screen. And then throughout the course of a gesture, you might get additional action pointer down and action pointer up events as more touch points beyond the first enter and leave the screen. Now, each one of these pointers has an ID attached to it. And these can be used to track the same touch point when you have multiple touch points active. Action pointer down is the start of a specific pointer becoming valid, and up is that pointer becoming invalid. So while a gesture is in progress, you'll get this steady stream of action move events as those pointers move around. These events contain info about every touch point that's currently in contact with the screen. And you'll have been told about each and every one of these through either the initial action down or action pointer down events. And if any of them leave the screen, you'll be told through an action pointer up or the final action up event. Action up or action cancel ends the current gesture in progress entirely. It means the user's done interacting with the screen for the time being. Action up means that it ended normally. Action cancel means that something else took the user's control away from your view. So what this means is that action up is where you should do things like fling or actually apply a click event. Whereas action cancel should never commit an action, because you never really know what took the user's control away from that view. Now, when you have multiple views working together to form your UI's full touch interaction, it's important to factor that interaction appropriately across your different views. Now, Android gives you several tools for views to collaborate and decide which view should actually be responsible for handling a current touch interaction. Now, onTouch event is the simplest of these. If a view returns true from onTouch event for an initial action down, then the rest of the event stream will be sent to that view. So it'll try and find the deepest view that will accept a touch event. It's kind of like focus for touch events, really. Now, parent views have an additional method that they can use for this, and that's onIntercept touch event. This will be called for each event that one of the parent view's children receives. By returning true from this, the parent can go ahead and steal the event stream away from the child view. The child will get an action cancel event, since that's what a view receives whenever the event stream is taken away from it for some reason. And then the parent will receive the rest of its events, or rest of the current event stream through its own onTouch event method, not through the onIntercept touch event method. Now, onIntercept is a great way to implement things like scrolling and dragging, but it can really be insufficient if you have several levels of nested views. Now, list views inside view pages are a great example. So to handle this case, we have this method that, once again, what is it with our framework having all these mouthful of constants and methods in here?
So we have to be very specific in the names.
Right. So we have request disallow intercept touch event. Now, by calling this method on a parent view, a view can stop the parent's onIntercept method from being called for the remaining events in the gesture. And in the case of something like the list view inside the view pager, list view invokes this method, and then it actually will lock the pager to the current page. The pager has no idea that you're moving back and forth left and right, and so therefore you won't move between pages if you just want to make a really sloppy scroll within that list. So speaking of sloppy scrolling, oh, well, in a second. Anyway, one way or another, these three methods, when put together, it means that you can write custom views and view groups without being too concerned about how you're going to compose them. And this is really important. It means that you can sort of keep all these concerns separate within the different custom views that you might write. The right thing will just happen naturally as long as you don't nest scrolling along the same axis. I mean, how many times have we all been using a web page and we'll go ahead and scroll with a mouse wheel or something like that, and then suddenly scrolling stops because there was this other internally scrolling region that your cursor just happened to be hovering over. You don't want to build that within a touch UI. So for this whole game of rock, paper, scissors to work, you really need an opportunity to determine the user's intent before committing to one action versus the other. And view configuration is a class in the framework that has a lot of constants and other values that sort of control how the framework tunes these sorts of things. In this case, you have get scaled touch slop. Now, this is going to be a distance reported back to you in pixels adjusted for the density of the current screen that is the distance that you have to travel in terms of touch motion before you actually commit to scrolling within that view. So having this slop within that gets checked within your onIntercept method for a scrolling container means that the child views have an opportunity to say, no, actually, I want this event stream, and call request disallow intercept touch event up to the parent, so on and so forth.
Yeah, and view configuration is a very useful class if you're doing anything useful in your custom view, like touch handling or even animations or drawing. You might want to take a look at view configuration and the kind of data it exposes, because everything in that class is meant to help you be consistent with the existing UI toolkit. So if you want to use, if you need a duration, there might be a duration in there that matches your needs. So make sure to take a look at it, and the class is actually pretty well documented. You can once again look at the source code of the Android platform and see how we use it.
That's right.
So we have 4 minutes left for questions. So if you have a question, please walk up to the mics in the aisles. And before you leave the room, there are barcodes by the doors. You can scan them if you want to rate the session. And we'll be at the office hours on the floor to answer all your questions throughout the day.
That's right. Thank you for coming.
Hello. I have a question. I want to implement a view that's like a heartbeat, like it's pulsing.
Okay.
But so what I wanted to do is like I will have like a method like it pulses every millisecond or every second or so, and I wanted like animation that pulses back. So how should I do that? Should I have like in my view some kind of timer that draws the circle smaller and smaller every 20 milliseconds? Should this be part of the view or?
So you should definitely use the animation framework, and tomorrow I'm giving a talk with Chet Haas on animations, and this is the kind of animations that we're going to talk about.
Okay, and the other quick one is some phones, they send you back up event after 15 seconds, something like that. Let's say the original Atrix. I want to have like a button which is like press and hold, but after 15 seconds it gives me an up event. How can I do that?
Yeah, that was the same on the Motorola Zoom, wasn't it?
Yeah, sounds like a bug in the touch driver.
Any workaround for this? Do you know about? That's your problem.
Yeah,
I would have to think about it.
Unfortunately, that's one of those things where there are some devices out there with touch firmware that try and do this. It's basically because the device is trying to account for noise or other sources of error that might be in the environment so that you don't have this permanent touch point down. Unfortunately, it ends up being way too aggressive, because if you're in a case where you're like holding down the gas pedal in a racing game or something like that, that becomes really problematic. And unfortunately, there's just not a whole lot you can do about it.
Okay, thank you.
Hi. So when you started, you mentioned that there was a blog post about relative layouts that was misinterpreted. Yeah, it was misinterpreted. Everybody I know follows that. So could you elaborate on that a little bit?
Yeah, so I think the original post was about not using a linear layout with an image view and a text view, and using only a single text view, or maybe you could use only or it was about using a relative layout to avoid nesting linear layouts.
That and weights, I think, as well, right?
Yeah, something like that.
It was specifically in the context of list items too, right?
That's correct. Yeah, it was the context of list items to avoid nesting a vertical linear layout in a horizontal linear layout. So it's still true, like if you're using weights, but using a relative layout to do everything is not the right answer. So if a frame layout does the job because you need to stack views, or if you just want to put the views side by side, go with a linear layout or a frame layout.
Right.
Relative layout will always do 2 measure passes. So when you nest them, you get an exponential measurement algorithm.
Thank you.
Okay.
Wrap it up.
Last question.
Hi, I have a custom view that draws a background shadow, and I noticed that it works okay until 4.2, and in 4.2 I get some visual artifacts that are strange. Is there anything that changed in the rendering?
Not that I can think of. It might be a bug on our side, or you might have been relying on the behavior of the on a bug that existed before. I would need to see code and a running example send me an APK that reproduces the issue and we can take a look at it and see if it's a bug on our side.
Or if you'd like, we'll be in the sandbox area
Or
right
office
after
hours.
this.
And if possible, another question. Is there an easy way to add margins to a list item entry?
To what?
To a list view entry to add margins, because the margins are cut by the list view.
Oh, you should use padding instead.
Even if we have a background?
Well, you use padding in the parent view and then you put the background inside.
Okay,
Right.
thanks.
Thank you.
Hey,
We are out of time. Come to the office hours in the sandbox.
Yep, happy to answer your questions at office hours. Thanks.